So we kind of talked a little bit about some of the setup for the section. Now we're going to write down a couple of definitions. So this is definition, and this is called the derivative. So we'll say the derivative of x of f of x at x equals a. So the derivative of f of x at x equals a is the limit of the difference quotient and then we'll say if it exists. So we're going to write down the first definition that we're going to use to calculate derivatives. This will be f prime of a equals the limit as h approaches 0, f of a plus h minus f of a, all that over h. So this is going to be the equation we calculate when we want to figure out the derivative of something. Or this is one of the equations we can calculate. So when this limit exists, we say that f is differentiable at x equals a. And then we're going to get an equivalent definition, which is the other equation we generated earlier. So an equivalent definition is, we can say f prime of a equals the limit as x approaches a of f of x minus f of a, all that over x minus a. Okay, so those are our two definitions of the derivative. I tend to work mostly using this definition, but occasionally this one's easier to calculate or is less work to figure out. So it kind of depends on the problem. Also depends on the AP test, what format they give. Sometimes you need to know both. Sometimes I'll have a problem in this form, or sometimes it'll be in this form. The next thing we need to do is define the tangent line. So we're going to do that down here. So we'll say definition tangent line. So we say, assume that f of x is differentiable at x equals a. So assume that f of x is differentiable at x equals a. The tangent line to the graph of y equals f of x at point P, which equals a, and then the y value corresponding to a, is the line through P with slope f prime of a. So the slope is the derivative of the function at the point A. The equation that they're going to give us of the tangent line is, and they're going to give us the point slope form. So this is going to be y minus f of a equals f prime of a times x minus a. So this is the form our book uses. We want to recognize there's a real easy way to generate a second form. If instead of subtracting f of a, if we move the f of a across the equal sign by adding it, we could also generate y equals f prime of a times x minus a plus f of a. And the AP test uses both. So you have to kind of be familiar with both of these forms of the equation of a tangent line. So we'll do a couple problems after this where we look at generating a few examples and see how to use this stuff. So we got our two derivative forms, and we have our tangent line, equation of a tangent line, two forms of it. Well, they're really kind of the same form, it's just this one scoots across.